Nick, Vice President. Okay. All right, so thank you all for coming out. This is a really exciting talk we have up here. It's Dr. Randy Olson. He's a PhD from MSU and now at UPenn. And he has his own intro section, so I won't steal too much time. Without further ado, here's Randy.
And there we go. There's my slides. All right. Yeah. Thank you for inviting me out. I've been, pretty excited to come back to state, come back home. I graduated about a year and a half ago, and time really flew. I'm actually turning 30 in February, which is extra scary. So so I thought I'd come and give a talk about actually a couple things. One, which will be the second part of the talk. I'm just going to talk about some of the machine learning and optimization work that I've been doing that I think would be relevant to this group and to people just getting into data science and all that good stuff. But I also thought I'd talk about, to begin with, just some general advice and some things about data science, and maybe we can even have a short break in the middle of the talk for you to ping me with questions or whatever you want to do. But anyway, for those who have no clue who I am, I'm Randy Olson. Hi. So I'm an AI researcher by trade. So I get to work in a very cushy academic job where I get paid to sit around and think and program and make new things. It's pretty nice. I did my bachelor's in computer science at the University of Central Florida just because it was convenient. It was like 20 minutes away from where I lived at the time. Graduated there, and then graduated from state with a dual degree in computer science and ecology, evolutionary biology, and behavior, which basically means I took a few biology classes and can sort of speak that language, but don't try to go too into depth. I probably won't be able to follow. And of course I have to say, go green, everyone. Although I love this comic I saw the other day, and it's only 1 month until basketball season. This year has been rough for football fans, but moving on. So after I graduated from state, I went straight over to Philadelphia, to the University of Pennsylvania, to start a postdoc position there, which is basically more research, same terrible pay and benefits, but still cushy academic job. Was there for a year, and then I just happened to be in the right place at the right time. One of the staff quit, and I immediately jumped on that cushy academic staff job. So now I have this nice title of Senior Data Scientist at the Institute for Biomedical Informatics at Penn. And we work on some really cool projects there, one of which I'll talk about today. And basically I get to do all the things I love, data visualization, data wrangling, machine learning, and write about it, talk about it, all that good stuff. And how I actually got to that, in part, was because I started up what I like to call this data tinkering hobby, right? So I guess somewhere in my second year or so, to distract myself from doing my PhD, which is what PhD students do, that's why we take forever to graduate, I started up a blog. Simply randallolson.com/blog, and I started working on weekend projects. I just would start finding data sets and all kinds of other things to play around with, analyze them, visualize them, and then write them up to sort of practice writing too, because writing is quite important, at least as an academic. And it turns out some people found that pretty interesting. I started sharing it on Reddit, especially this Data is Beautiful community. Is everyone familiar with Reddit? I think a lot of folks are. So Data is Beautiful is a really great community for, I would say, data scientists in general, for sharing your work and for getting feedback on your work and all that good stuff. And I also, of course, because I posted so much there, they eventually invited me to help moderate it and all that good stuff, so I can call myself a community leader for that group. To begin with, I thought I would say, I'd put out a special announcement there that if you missed this talk, what was it, a few weeks ago?
I think 2, right?
2 weeks ago?
Oh, no, 4 weeks already.
Time's running. It's been a while.
Yeah, a month. Oh.
Anyway, if you
I
want
know
to...
it was on YouTube.
It is on YouTube, yeah. I actually watched it before I came here. And that's why I can wholeheartedly recommend that if you want to have, see some really great advice about, getting started with data science, delivered by a younger and more attractive guy, you should go and see Sebastian's talk on YouTube. That's the link to the first video. It's a 4-part series, and I thought he did a really good job with it. So yeah, so go and check that out. And I just thought for the rest of this section, I would add in some more things that might be useful, that might be good to know. So when I was preparing this talk, I was sort of just looking around the web and thinking about, okay, what do I want to talk about? And I ran across this really nice post on Udacity called The Core Skills of a Data Scientist. Has anyone seen this post before? No? Yeah, see? Perfect. So I really like this post, actually. I thought they did a really good job of summarizing not only the core skills of a data scientist, but also importantly showing that there's actually not just like one type of data science job, right? So I figured I could go through this chart and maybe point out some interesting things and talk about them. And of course, please feel free to ask questions as we go along. So yeah, can everyone see this chart okay, even in the back and everything? Yeah, cool. Yeah, so highlighting these, I guess. So yeah, so they basically said that there's 4 kinds of data science jobs out there. One of them is really a joke, but I guess it's a real thing, which is basically a data scientist is a data analyst who lives in San Francisco, right? So, if you're there is a distinction between data analysts and data scientists, right? Data analysts typically don't go too in-depth when working with data. They're working with a lot of databases, cleaning data, yada, yada. Data scientists get to do the fun stuff, in my opinion. But because it's such a sexy title to have, I mean, that's why I went after a senior data scientist position. A lot of people just call themselves data scientists, especially when they're in the right area. It certainly helps with your job prospects. Another kind of job out there is basically the please wrangle our data job. So this is a company that's heard a lot about data science, heard about the value of data-driven decision making and all that good stuff. Probably some business type sold them on the idea. And so they want to hire a data scientist to start their data science team. So this is usually a first-time hire for them. They're just getting into data science. And they basically just want you to help clean up their data, maybe do some really basic stuff for them. But you're going to have to be pretty independent there, right? There's no existing data science team or anything. So this is the kind of job I would love, right? Like I like coming in with no guidance and just screwing around and pretending like I'm an expert. Anyway, so the next kind of job is a We Are Data. I would say it's Data Are Us, but I guess that sounds a little silly. Toys R Us, but anyway. This is the kind of job, this is where the really hardcore data scientists go, right? These are especially people with physics backgrounds and things like that, mathematics backgrounds. They're really doing, hardcore data science and machine learning algorithm development. So one great example is probably, Uber. They're doing some pretty great data analytics there, and they're constantly improving it, as I've really enjoyed to see. They're really active in Philadelphia. Yeah, and then the 4th kind of job that they say that's out there is a reasonably sized non-data company who are data-driven, right? So these are companies that don't necessarily, have a product that's, some data science thing, but they still make data-driven decisions. They collect data about what they do, and they use that data to decide, who's best to market to, for example, something like that. So this is the kind of job where you'll be able to join an existing data science team, maybe as a junior data analyst, or if you're more senior, you can as a senior data scientist, and you'll have some more guidance there, right? You'll be a part of a data science team, you'll be given specific tasks, so that's a pretty nice place to start out. The We Are Data Are Us group is going to be pretty hard to jump into. I would argue that there is a 5th kind of job, which is basically, to play on the first one, a data analyst who works in academia, also known as a scientist. But to be fair, like data science jobs in academia can sort of fit in the last 2, right? We could, if we think of an academic lab as a company, which it technically is, right? We produce academic papers, we produce software, and once we do that enough, the government gives us money, and our little business continues. There's also, like, for example, my position, I would say we fit in the We Are Data Are Us kind of thing, right? We're doing constant algorithm development and all that good stuff. Any questions about data science positions so far? Cool. So the other thing that I really liked about this chart was that they broke it down by the importance of various skills for those positions. So one of perhaps the most frustrating things for me is, well, I mean, I love that I get emails from people asking questions that are interested in data science. But one of the most common questions that I get all the time are, what are the tools that should I, what tools should I learn? What are the important ones to learn? Should I learn R or Python or whatever else? And what I really wanted to point out in this chart is, yes, tools are important for every job, right? You should learn R, you should learn Python, you should learn, SQL, other database languages, to learn how to analyze data, visualize data, all that good stuff. Learn the tools for that. But there's so much more that you should, I don't want to say that you should worry about, but there's so much more to learn and to do as a data scientist, right? So that's an important thing to point out, I think. Another thing I'd like to point out is that machine learning is really, really hot right now. People they're just going nuts over it. There's all these great machine learning and deep learning libraries coming out, and it might actually give you the idea that that's a lot of what data science is, right? That, we're just going to take data and apply magical machine learning models, and we're going to find this amazing insight, and that's all we do. No, that's not what you do at all, really. A lot of companies don't even want that, right? Especially companies that are just getting into data science. They want really simple analytics. At the University of Pennsylvania's hospital, their data science team, they're very disappointed in this, but they literally just do counts, right? They just count patients based off of, injuries or other things, whatever they're categorizing by, and then just provide counts, and that's all the physicians need, but that brings extreme value to their group, right? So some of these positions, you don't even have to worry about machine learning. Of course, it's good to know. It's always good to have another tool in your data science tool belt if you want to consider yourself like a data science Batman or Batwoman, but it's certainly not necessary. And I say that even though the second half of my talk is going to focus really heavily on machine learning. So please do be hyped about machine learning, because it's very cool. So the last thing I wanted to point out on this chart is that, yes, tools are important. Machine learning is maybe not as important as it seems to be based off of the coverage it gets, but every data science job requires good communication skills, right? And I think this is something that's not stressed enough. It's something that I realized early on. That's actually why I started my blog. I wanted to start practicing. How do I communicate these findings I'm making during my regular job? How do I visualize things well? How do I write about them well? That's something you need to practice. You're not just going to magically, be good at it one day if you take enough courses or whatever else. That's something you really need to practice. And that's why I thought I'd sort of end this section with some basic advice. One of the biggest pieces of advice I'll give you is to regularly work on personal data science projects. Like not even, the projects that your profs assign you or whatever else. Have personal projects that you're really passionate about, that you're really interested about, and work on them on a regular basis. For me, I had no life during grad school, so I basically spent almost every weekend working on little projects that I would write about on my blog. And I think another important thing to point out here is that you should start small. So I've been lucky to be involved in a data science community in Philadelphia. And I meet a lot of people who are just starting out. They're following this advice. They're saying, yeah, cool, I'm going to work on some personal projects on the weekend and work with like the local public transit data or something else. But they come up with this like fantastic, huge project that would take an entire company to make, and they spend months working on it and they learn a ton. But at the end of the day, they probably fail because it's this huge project that takes way more skill than they have, and so they don't really have anything to show for it. I think that's actually really important, is to work on small, little incremental projects that show, hey, I learned this skill, or hey, I mastered this skill, and I can show it off, right? Because I can tell you, whenever I'm looking at applicants for a data science position, I'm looking for those little projects. I'm looking for your GitHub code. I'm looking for, basically, were you going out of your way to learn this stuff beyond the classroom, right? Or even if you were in the classroom, did you think to post it online? Because that really helps me find out how good of a data scientist you are, how good of a programmer you are. So keep that in mind. And especially, I think what's really great about this, was useful for me, is it'll help you learn to tell a story through data, right? That's a very different skill than just telling a story normally. You have to sort of look at a data visualization or look at some statistics that you calculated and somehow turn that into a story and relate it to something that's relevant to people, because most people don't care about statistics and about visualizations and all of that. So if you can make that relatable to people, that's a really useful skill. And then of course, I'm pretty sure this is something Sebastian touched on too, share your work. I put it on a personal blog, but if that's too much, I put it on WordPress because I hate doing web dev. But there's medium.com, there's Reddit, there's Imgur, all that good stuff. You can post it on there and share it. Get feedback, especially get feedback and learn to take constructive criticism, right? So one thing I'll note is that when you put stuff on the internet, you're going to get probably constructive criticism, but you're also going to get a good amount of negative criticism. People will just say, this sucks, just quit. What are you doing? I still get this all the time. And you learn, sometimes you can find, useful criticism within that. That takes a lot of practice and a lot of patience. But at the very least, learn to identify constructive criticism. Because sometimes it may look like they're being very harsh and very critical, but they're actually trying to be positive and they're trying to help you out there. So I think that's a very useful skill to have. Another piece of advice I'll give is to take some social media seriously. So whenever I'm mentoring students, one of the first things I do is I strongly encourage them to make a social media presence. That means also make a website, make a blog, get on Twitter, maybe get on Reddit. I don't know. So sometimes that's useful, sometimes it's a distraction, and definitely get on LinkedIn, right? And because each of these social media websites that I list here, they have very distinct uses that at least I found over the years if you use them right? So, Twitter is very useful for connecting with like-minded techies. There's a pretty large data science community on there that's constantly sharing information. It's a great way to get in touch with those people. And most importantly, I think, is to make yourself known as that person who does X. So right now you may want to be that person who does data science or whatever else. But I will note, be very careful with what you tweet about and what you do. Be very careful about what that X is, right? For me, most recently, because I did all these road trip posts and these optimized road trip posts, I'm the guy that apparently only does optimized road trips, and that's all anyone ever wants me to do anymore, which is kind of frustrating, but anyway, at least I'm known for something, I guess. But yeah, think about when you're tweeting, when you're on Twitter, what you present on Twitter. Think of it as a professional profile, and think about, if someone visits your Twitter page, how are they going to perceive you? You're going to be the person who does what, right? The person who complains about football or hockey or whatever else, or is it going to be something more professional? Think of Twitter as a professional network. Another social media website that I found very useful is, of course, Reddit, for two reasons. For one, if you go around on the right subreddits, don't go on r/funny or don't go on r/pics or cute animal pictures or whatever else. It's a nice distraction, but I've found it as a great place to find inspiration and also to share my work, right? So here's a few of the subreddits: Data is Beautiful, Machine Learning, Data Science. These are all really nice, more professional subreddits that are focused on sharing sharing relevant information to the field. And actually, I'm biased because I'm a moderator of Data is Beautiful, but Data is Beautiful is by far one of my favorite subreddits because every day I go and look on that front page and I see a data set, or I see a new way of visualizing data, or a new way of analyzing data, and even if I think, inside, wow, this is really crappy analysis, I see that little gem in there and I go, oh wow, we could do this better. And that's the important part, is you see an opportunity to do something better, and hopefully they share their code and they share their data, so you can build on top of that, right? So it's a really wonderful place to find inspiration for your work. And even when you're just starting out with some of the small projects I was talking about, you can go to some of the top posts on here. Sometimes people are nice enough to share the data and or the code of how they did it. You can try to replicate it or whatever else, which is a great way to start. Although, of course, give credit back if you basically just copied someone's code. Last thing I thought I'd mention is LinkedIn. So I'm honestly not very active on LinkedIn. I guess some people like to treat it as a professional website or whatever. But one thing I have noticed is that it's pretty great for finding jobs. So actually, the job I have now, I found through Twitter, surprisingly. But when I recently changed my title from, I forget what it was before, like postdoctoral researcher or something really generic, I put senior data scientist in there, and the number of job offers I got per day friggin' skyrocketed. So I'd imagine anyone who lists themselves as a data scientist on LinkedIn is going to get quite a few job offers. So if you're on the market, don't list yourself as seeking a job or whatever else. Just put data scientist. And as long as you can back it up with actual data science skills, you'll probably find a job. Lastly, I thought I'd fill in a couple books that I recommend. So these are 2 books that I've read through, I've really enjoyed, and best of all, they're technically free. So they're published as ebooks, and you can pay what you want. So they usually ask for like $10 or something, which for both of them I ended up paying for them, but I still have that like cheap student mentality, so I'm like, give me it free first. But both of these books are really great. The one on the left, the Data Science Handbook, is really fantastic, especially, if you're just getting into the field now, get this book and read it. It's fantastic. It gives you so many great perspectives on more senior data scientists, and basically, if you're coming to these talks to try to get a perspective on what's it like to be a data scientist, how did you get into the field, this is 25 really well conducted interviews of really big people, really big names in the field, talking about how they got into the field, their opinions on various softwares and various other things. Yeah, it was an amazing read. So I highly recommend that book. The other one that I really enjoyed was this Elements of Data Analytics Style. And it's because it's a very bare bones book, to be honest. It's not like a pleasure read or anything. Like the one on the left, I was like, oh wow, this is so well written. This is such a nice story. The one on the right, very bare bones, but straight to the point. And what I really liked about it was one of the last sections there basically has like a data analytics checklist. So it says, okay, you get a data set, follow this checklist, and you're going to, perform a pretty decent analysis if you follow this checklist. And they touch on some things that I think don't get touched on enough, like reproducibility, actually having a hypothesis, like an idea of what you're going to show with your data before you just start, mining it all over the place for an answer. Yeah, so also a very, very good read. Like I said, both free, pay for it later when you love it. So that's it. Ooh, excuse me. That's it for the initial section. Did anyone have any questions about data science or anything while I catch my breath? My breath? Man. Okay. Yeah.
I'm not sure if you may have mentioned it earlier in the talk, but how prevalent is machine learning to your everyday?
To my everyday?
Yeah.
It's basically my life. But I should say that. I do machine learning every single day. But that doesn't mean. Were you here for that slide?
I actually just got here.
You just got here. Okay. Yeah. So I'm sort of in this group of we are data RS. Where basically I live and breathe algorithm development. And I'm hired to basically do machine learning. But there are plenty of data science jobs out there where you don't need to do machine learning. In fact, machine learning is going to be overkill. I'll say yes, I do tons of machine learning, but that is a bit of a niche